Wait, if you want to score full marks on finding the fastest molecule in your exam just by looking at the formula, watch this video until the end. I'm going to show you the secret trick. Have you ever noticed that when you come home, some curries reach your nose much faster than others? Or why you can smell a fresh spray of perfume from across the hall almost instantly? Today we are learning exactly why that happens. Welcome to lesson 1.5 Diffusion, where we discover which particles are the fastest runners in the chemistry world. As usual, I'll be showing the tute on the left and the whiteboard on the right. So look at page 1. Diffusion is just particles moving from where there are lots of them to where there are fewer of them. Why? Because particles in liquids and gases move randomly and rapidly. Think of them like tiny bumper cars crashing into each other until they fill up every corner of the room. So if you look at the second poem, which is the perfume in a hallway analogy, the perfume particles diffuses through the air, and that's why we can smell it even if someone uses at the other end of the hall. Before we get into the lab experiment, let's look at the simple logic. In chemistry, the golden rule is heavy ones are slow and lighter ones are super speed. Think about it like this. When your stomach is light and empty, you can run easily. But after a heavy meal, you're slow and it's difficult to move. Particles are exactly the same. So how do we know if molecules are heavy or light? Finding the molecular mass of the molecule, we can check if it's heavy or light. Let's see how to find the molecular mass. If you are 100% sure on how to check the mass number of a molecule, you can fast forward the next part. But if you are not, keep watching. This is simply the addition of protons and neutrons. We don't count the electrons because they are too light. To find the weight of an atom, we look at the mass number. So the mass number is basically the addition of proton and neutron. So you know that when nitrogen is number 7, the atomic number in the periodic table is 7, which is equivalent to the proton. And then the mass number is written on top, which is the addition of this proton plus the neutron, and that gives us the 14. This is the mass number of nitrogen. For example, let's take ammonia, which is NH3. In the periodic table, nitrogen has a mass of 14 and hydrogen has a mass of 1. But we have 3 hydrogens here. So we have 1 nitrogen and 3 hydrogens. So 14 plus 3 times 1 would give us 17. So the molecular mass of ammonia is 17. Let's try another example. So let's try to find the molecular mass of HCl. So HCl. We know the atomic number is 1 and the atomic number of chlorine is 17. The mass number of hydrogen is 1 and the mass number of chlorine is 35.5. So the molecular mass of HCl is the addition of the mass number of hydrogen and chlorine, which is 1 plus 35.5, which should give us 36.5. When we compare ammonia and HCl, we obviously know that HCl is heavy. The reason is the molecular mass is more compared to ammonia. Exactly what the tute says. Ammonia is lightweight and fast. Hydrogen chloride is heavier and slower. Hope you understood how to check the molecular mass of the molecules. So in the Cambridge chemistry book, there's an experiment where If you put these two gases in a tube, they meet closer to the heavy end, which is HCl, and it would form a white ring. So the reason why this white ring forms towards the HCl side, not in the middle, is because the molecular mass is affecting the speed of diffusion. To understand this better, imagine two people running towards each other in a long hallway. So this person has an empty stomach and this person has eaten a lot of food. So obviously we know that the person on the left would feel very light and he could run faster, just like ammonia. But HCl feels very heavy after a meal. So just like HCl, he would be running very slowly. So who do you think would have moved more by the time they meet? Exactly, the light person covers more ground. In the lab, these gases meet in a tube and form a white smoke ring. So the light one basically wins the race. Let's move on to the effect of temperature. Finally, remember that the heat is equals to energy. So as the temperature increases, the rate of diffusion increases as well. Also, you would have noticed that the tea diffuses faster in hot water because those particles move faster. So pause the video and try these practice questions. You'll get similar questions in your exam. Try the question and comment your answers in the comment box. So the second question says, which gas will diffuse faster, carbon dioxide or helium? And the mass is given, which is 44 and 4, the molecular mass. So we obviously know that carbon dioxide will diffuse faster since the molecular mass is high compared to helium. Final exam tip: always use the phrase random movement when explaining diffusion. And if you see that white ring in a diagram, it's always huddling closer to the heavy, slow gas. If this heavy meal trick made sense, like my video and subscribe to the channel to continue the completely free course of science lesson. You've got this. See you in the next one.